Our fascination with the heavens is as old as the human race. What started as a mystery, filled with wonder and fear, soon evolved into a calculated system of understanding the seasons, identifying the four directions, and accurate navigation. The star constellations that had been used to explain gods and legends were now working to advance civilization. Today, man-made constellations are in the heavens. Their purpose? To provide instant, exact global positioning information. This global positioning system, or GPS, is revolutionizing the modern construction site, automating and guiding equipment, providing instantaneous surface and volume data, simplifying topo and control surveying. Nearly everyone involved in the surveying and construction industry has heard something about satellite positioning technology. Or maybe you or someone you know is already using it. Whether an operator or casual observer, there are still many questions about how this exciting new system really works. These positioning satellites don't stay in one place like the stars. They orbit the Earth about twice a day, constantly transmitting uniquely identified radio signals that can be received by specialized units on Earth. These signals are used to precisely measure the distance to the receiving instrument from each satellite visibly overhead. Just as stars have exact locations in the sky, the locations of the GPS satellites are also defined, becoming orbiting reference points. Using a process based on triangulation, a GPS receiver processes the signals from multiple satellites to compute an accurate position on Earth. For mobile applications that require high accuracy, such as three-dimensional machine control and topo collection, there are two requirements that must be met. First, the signals from a minimum of 5 satellites must be received at all times. And second, those 5 satellites must be distributed across the sky. This is called dilution of precision, or DOP. The simple rule of thumb is this: the more satellites received, the better your system will perform. All TOPCon receivers incorporate standard GPS satellite tracking technology. Unfortunately, the GPS satellite constellation alone cannot continuously meet the minimum requirement of accurate mobile positioning. For any given location, there are times in a day where there are less than 5 available satellites, or very poor DOP. Now, consider a job site with trees, buildings, or other obstructions where satellite reception can easily be further reduced. All GPS receivers suffer these same problems because they all use the same satellites to operate. Even the planned signal modernization to the GPS satellites won't solve this problem. An obstruction that blocks one signal blocks all signals from that satellite. TOPCon has solved this problem. The solution isn't adding more signals from the same satellites. It's adding more satellites. Today, there is a second positioning satellite constellation in operation, the GLONASS system. This positioning system is operated and maintained by the Russian government, much like the GPS is operated and maintained by the United States government. Combining these two satellite constellations gives you access to 38 different satellites, 14 more than a GPS-only system. The additional satellites mean stronger, more accurate positions and better performance in obstructed areas. These additional satellites mean maximum uptime in all locations, in all conditions. Only Topcon provides the productive advantages of GPS plus GLONASS satellite tracking. We call it GPS Plus. GPS Plus has made stakeless grading a reality on countless job sites. The advantages of a unified control, simultaneously operating multiple pieces of equipment, has provided vast improvements in productivity and rough grading quality. However, one frontier remains: multi-user precision fine grading. Although GPS is very accurate for horizontal X and Y location, its vertical accuracy is only assured to a few centimeters, about 1/10 of a foot. This limitation has prevented GPS control of many precision applications, such as finish grading, curb staking, or mobile 3D surveying. These applications have required the use of a dedicated optical system. But not anymore. Now, there's Laser Zone. Topcon's revolutionary technology that turns your existing GPS Plus system into Millimeter GPS Plus. Topcon has invented an easy-to-use, low-cost accessory that can be added to your existing Topcon GPS Plus system to instantly provide millimeter-accurate vertical control. Topcon's innovative Laser Zone transmitter projects a unique laser signal that creates a high-precision measuring area 33 feet tall and 2,000 feet in diameter. Much like using a conventional rotating laser system, simply set up the Laser Zone transmitter conveniently on your job site. Attach the compact Laser Zone receiver to your Topcon GPS rover. For 3D millimeter GPS, mount the integrated GPS Laser Zone receiver to your equipment. This integration of advanced technology provides Topcon users with the ability to control multiple fine grading and layout operations from just one Laser Zone transmitter. The Laser Zone system determines its precise elevation automatically, anywhere in the 33 feet high zone. For larger or steeper sites, up to 4 Laser Zone transmitters can be linked to cover a distance up to 1.5 miles and an elevation change of over 130 feet. Only Topcon gives you GPS plus GLONASS. GPS plus Laser Zone, combining maximum uptime and millimeter accuracy. It's all about productivity. More satellites for maximum uptime in all conditions. It's all about performance. Millimeter GPS. GPS productivity for your most demanding work. It's all about the plus. TOPCon GPS Plus. The advantages are out of this world.